So in this video, we are going to talk about converting from standard form to vertex form. So let me start by saying if we want to go from standard form to factored form, really all you have to do is factor, and then you get your factored form. So we're not going to focus on that, but we did learn a method of converting from standard form to vertex form, and we did that by completing the square. So that's the method I'm going to show you in this video. I'm going to walk through 4 different examples just to show you a variation of how you would set that up. So let's look at this first one. I had tiles pre-drawn for me to use. On the next couple examples, I'm just going to draw them in myself, so they may not be as neat, but these are the types of things you would draw on your own to help you. So let's look at what we have here. So my example is x squared plus 6x plus 9. That is in standard form. I have my x squared term, my x term, and my constant, okay? When we are completing the square, we are drawing exactly what we see in our problem. So do you notice how I have an x squared? So I have an x squared. I have 6 x's. So I have 1, 2, 3, 4, 5, 6 x's. And then I have 9 1s because there's no x's there, it's just a constant. So I have 9 little tiles here, okay? So that's what we're gonna be referencing. The first thing that I have to mention about completing the square is we are quite literally completing a picture of a perfect square. So when you're arranging your tiles, keep in mind you want your tiles to literally make a perfect square, okay? So I have an x squared tile. I'm gonna move these x's. So normally, let me go back to this. Normally if I have my area model, my x squared term is here, I have whatever my x's are here, and then I have some constant, right? I'm gonna put c. So that's kind of how it's set up. So that's how I'm gonna set up this. So I have an x squared, and then I have 6 tiles, but in order to make that perfect square, I need even sides. So I'm gonna end up moving those 6 squares. I'm gonna kind of split them in half, and I'm gonna put 3 on this side. Adjust it just a tad. Okay. And then I'm gonna put 3 on the other side. So if you notice, I have 6 purple X's, okay? And then if you look, well, I have X times X. I have an additional 3 X's here and 3 X's here, so let me write this in. I have X times X. I have plus 3 more over here and plus 3 more over here. And then if you notice this blank space, I'm gonna fill in with those little tiles that I have. So these little tiles, I have 9 of them. So I'm going to go ahead and take these and move them here. So I'd have 1 here, I'd have 2 here, I have 3, I have 4, oops, we have 5. Again, these are the things you would be drawing. I had them kind of pre-done just to make it a tad bit more organized. And then we have this one, 7, 8, and 9. Okay. So again, I had an x squared. I have 6 x's, so I have 1, 2, 3, 4, 5, 6, and exactly 9 tiles, which fits perfectly. Do you guys see how when I do that, I have this perfect square with all my tiles, okay? Your vertex form comes from writing the structure or area of that entire square. So here's what my vertex form is going to look like. The dimensions of this square are x plus 3 times x plus 3, which is the same as x plus 3 squared, right? Which means x plus 3 times x plus 3. That is my perfect square. So what I have right here in my perfect square that is described as that. This is my vertex form, okay? The next couple of examples are going to show us what happens when we don't have the perfect number of tiles to make that perfect square. So let's go ahead and look at this next one. Again, I'm going to draw these in, okay? So I have an x squared tile, so I'm going to draw x squared. I have negative 10 x's. So remember, we're trying to make that perfect square. So if I have negative 10 x's, I need to think about how many x's would go here and here to have that perfect length, the equal length on both sides. Well, if I split up 10, that's 5 and 5. But keep in mind that those x's are negative, which doesn't change too much. But when I draw them in, I have a negative x, another negative x, 3, 4, and 5. I'm going to do the same over here. I have 1, 2, 3, 4, 5. Again, these are negative x's. So I have negative 10 x's total. So let's go ahead and write in our dimensions on the outside. This is x times x. And then I have minus 5 over here because those are negative x's, so minus 5. And then I have another minus 5 over here. Okay. Now let's look at what's going on with this bottom corner. If I were to draw all those little tiles in, I will draw them in just for this example. So if I drew those in, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So in the next examples, I'm not going to draw every tile, but just know, do you see how I have 5 x's by 5 x's? So that's how I would know I have 25 there. Okay, but let's look at what's going on in our problem. Do you see how I have plus 16 at the end? Well, in our first example, I had exactly 9 tiles from my problem, and I could fit exactly 9 tiles here, okay? So I want 25 to be here, but I only have 16 tiles. So here's how we're going to write this. Y equals, well, what's the dimension of this perfect square if I had it? Well, that's just x minus 5 times x minus 5. So I'm going to put x minus 5 squared. But this is only the dimension if I had exactly a perfect square. I want 25, but I only have 16, so I'm actually missing 9 tiles, right? I only technically can fill in about 16 tiles here. Those other 9 I'm missing. So in my equation, I am missing 9. And as you notice, this is in vertex form, right? We'd go to the right by 5, down 9 to get our vertex. So whenever you have less than you need or even more than you need, which we'll see in a future example, that's how you would write your equation, okay? Let's look at the next one. Okay, this one's a bit different. Do you notice how there's a number in front of my x squared? Doesn't change too much, but now since I have 2x squareds, I'm going to draw 2 of those x squareds. Okay, so now I have 2 pictures that I need to draw because I said I have 2 x squareds. Okay, so if that's the case, let's look at my x's. I have negative 12 x's, but those x's need to be split up amongst both of these pictures to make 2 perfect squares. So we have to ask ourselves, how many x's would each picture get? Well, if I have negative 12 x's, each picture would get negative 6 x's. So I get to put 6 x's here and here, but that leads me to say that I have to split 6 in half to go in those 2 spots. So technically, I have negative 3 x's. on both of those. So I have 1, 2, 3. Those are negative x's. 1, 2, 3. Again, those are negative. And then we would do the same for the other picture. So I have negative x, okay. So let's double check that we're good. I have negative 12 x's to use, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those 12 x's got dispersed between my pictures, okay? Now here's the part we have to think about. I have 32 little ones tiles that I can use. So let's look at our dimensions of what's going on here. Remember I said I'm not going to draw every single little tile. We just have to look at what's going on here. I have negative 3 x's by negative 3 x's. So 3 times 3, technically, I'm going to write that I want 9 tiles here, which means I also want 9 tiles here, okay? In total, 9 plus 9 means I need 18 tiles to make 2 perfect squares, okay? So let's start looking at our dimensions. This is x, I have minus 3, I have negative 3 x's, x minus 3. That's the same over here as well. Okay, let's start writing our equation. So my equation goes, well, if I had one perfect square, isn't that x minus 3 times x minus 3? So I have x minus 3 squared. But how many pictures do I have of that dimension? Well, in this case, I have 2. So in my equation, you are going to double or multiply by 2 out front of that perfect square, okay? But there's one more dilemma. I wanted 18 total, but I have 32. Don't I have more than I need? So now we think about, okay, I only want 18. So I'm going to take the 32 tiles I have, and I'm going to subtract 18 because that's all I want. So 32 minus 18 is going to get me 14. So technically, I have 14 extra tiles from my pictures for them to be perfect squares. So this is my vertex form. And again, we would move to the right 3, I'd move up 14, and then this is your A value, which is going to stretch your graph here. Okay, let's do one more. So my problem has 3x squareds, so I'm going to draw 1, 2, and let's put it just down below. 3x squareds, okay. I have 18 x's that need to be distributed amongst each picture. So that means each one is going to get 6, but again, to make a perfect square, those sides need to be the same length. So if each one gets 6, that means I'm gonna put 3 on each side. And then we'll count after to make sure our math is good. All right, let's double check I used 18 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We're good. Okay. Now we look at that last number. I have minus 2 tiles. When you have a minus amount of tiles, that means you're already missing some tiles. That means you're down 2 tiles. So I'm going to put that out here. I am missing 2 tiles. I'm already down. I don't have any to use. Let's look at what we want in those bottom corners. Remember, we don't have to draw all of them. This is 3 by 3. So I would want 9 here, which means I would want 9 here. And same for down here. I want 9, okay? So the dimensions, if I had a perfect square, the dimensions of that would be x plus 3. I have 3 additional ones on the side. X plus 3. It's the same for all of them because we're making 3 perfect squares because of that 3 in front. Okay, so let's start writing our equation. Well, if I had, theoretically, one perfect square, the dimensions of that square are x plus 3 times x plus 3, which is just x plus 3 squared. But we have 3 of those pictures. So I'm going to multiply that dimension by 3 because I have 3 of those. But there's a problem. I don't have 3 perfect squares because I want 9 here and also here. But I don't even have any tiles there. There's none that I can draw because I was already down 2. So this is how we make sense of it. If I had 3 perfect squares, that would be the end of my equation. But I'm missing 9, so technically I'm missing 9. I'm missing 9 more, missing 9 here. I'm missing 27 tiles on top of already being down by 2. So if I'm missing 27 and down by 2, I am missing 29 tiles to have 3 of those perfect squares. And again, in vertex form, I would move to the left 3, down by 29. That would get me to my vertex. And then that number in front is your A value. It would kind of stretch the graph up by a factor of 3 and make it really skinny. Okay. Hope that helped. And good luck converting from standard form to